Now we are to study the units of viscosity. To derive the units of viscosity, we will put all the units in this formula. Mu is equal to shear stress over change of velocity over change of distance. The formula that is unit of viscosity formula of viscosity. For shear stress is force upon area over change of velocity is length upon time into 1 by length. When you calculate this, force upon length square, if you cut this length with this length and force upon length square over 1 by time square, you calculate this, the SI unit of viscosity will become Newton second per meter square or Newton second per meter square, like this. So SI units of viscosity is Newton second per meter square. हमारी shear stress की वैल्यू फोर्स अपॉन एरिया होती है. फोर्स stress is equal to force upon area. Now change of velocity is length upon time and distance is L, 1 by L. Now when you calculate all these effects, you will get force into time over length square, that is equal to NS. N stands for force Newton, time के लिए second और length square के लिए meter square. So this is the SI unit of viscosity. Now kinematic viscosity. It is defined as the ratio between dynamic viscosity and density of fluid. It is denoted with Greek symbol called as nu. V की शेप में होगा, nu बोलते हैं इसको, and it is equal to nu is equal to viscosity over density. Dynamic viscosity that we have already studied. This is called dynamic viscosity, right? Mu over rho. The SI unit of kinematic viscosity is meter square per second. Newton law of viscosity. It states that shear stress on a fluid element layer is directly proportional to rate of shear strain. The constant of proportionality is called coefficient of viscosity. So simple सा rule है Newton's law of viscosity, that whatever shear stress is applied, it should be directly proportional to rate of shear strain. कितना strain produce होगा. The constant of proportionality will be equal to coefficient of viscosity, right? तो ये न्यूटन लॉ है. अगर कोई हमारा सब्सटेंस, फ्लूइड कह लो, गैस कह लो, ऑयल कह लो, if one element obeys this Newton law, when a fluid obeys Newton law, then we call it a Newtonian fluid. Those fluids which do not obey this Newton's law is called as non-Newtonian fluid. There is another classification, Newtonian fluids and non-Newtonian fluids. So fluids which obey the Newton's law of viscosity, that is stress is directly proportional to strain. Those fluids which obeys Newton's law of viscosity is called Newtonian fluids, and those fluids which do not obey the Newton's law of viscosity, those are called as non-Newtonian fluids. Now variation of viscosity with temperature. What is the effect of temperature on viscosity? If you talk about liquids, the viscosity of liquid decreases with the increase in temperature. When you heat some liquid, the thickness of that fluid gets decreased. As thickness decreases, the viscosity also decreases. So for liquids only, when temperature is rising, when we heat some liquid, its viscosity decreases. Its viscosity decreases, and on the other hand, the viscosity of gases increases with increase of temperature. लेकिन दूसरी तरफ देखें, लिक्विड और गैस को अलग अलग लेंगे इसके अंदर विस्कोसिटी के अंदर. जब आप लिक्विड्स की बात करेंगे तो जब उसको आप हीट करेंगे तो वो लाइट हो जाता है, लेस थिक हो जाता है. तो जैसे जैसे वो आप हीट करते जाएंगे, द फोर्सेस ऑफ कोहेजन विल गेट इफेक्टेड, और वो कम हो जाएंगी. विद द डिक्रीज इन कोहेसिव फोर्सेस, the resultant will be viscosity will decrease. In case of liquids, the predominant effect that is binding the liquid together is forces of cohesion. The cohesion forces are those forces which binds a particular liquid, right? And in case of gases, there is no forces of cohesion are not that predominant. In case of gases, molecular momentum transfer predominates. When we heat some gas, molecular momentum, the activity of that particular that molecule starts vibrating. Because of that, this the increase in temperature, the randomness increases, and in further the viscosity also increases. So you must know that in case of liquid, the viscosity will decrease if you heat that, or if you increase the temperature of that liquid. But in case of gas, if you heat that element, heat that gas, that the randomness of that element or that gas will increase, or momentum will increase. Because of increase in momentum, that viscosity will also increase. So to calculate or to study the effect of temperature, you can see the formula that is on your screen. For liquid, viscosity का effect study करने के लिए you can use this formula, and for gas you can use this formula. Right? I wish you all to please write this formula. In your notebooks. For liquids, mu is equal to mu naught 1 over 1 plus alpha t plus beta t square. Where mu is viscosity of liquid at T degree Celsius and mu naught is viscosity of liquid at 0 degree Celsius. Right? आपको 0 डिग्री सेल्सियस पे पैदा होना चाहिए विस्कोसिटी, और जिस टेम्परेचर पे आप निकालना चाह रहे हैं वो आप निकाल सकेंगे. Alpha and beta are the constant of the for the liquid. For water, the value of alpha is 0.03368 and beta is 0.000221. Similarly, for gases, alpha is 0.0000. I think it's 7 zeros and 5 6. Beta is 0.1189 into 10 raised to power minus 9. Right? So these are the formulas to calculate the effect of temperature on viscosity. Right? If you have any doubt on this, you can ask. Any question? So I am going to share you another poll.
The ratio between the weight of fluid to its volume.